Okay, last skill from section 5.8. So here I'm going to give you equations, and I want to know if those equations correspond with lines which are perpendicular. So perpendicular here means cross or intersect at a right angle or a 90-degree angle. So if you look at my picture here I have two lines, A and B. And these two lines, they cross at a 90-degree angle. So sometimes in geometry we make a 90-degree angle like that. So this is 90 degrees. So these are perpendicular. But let's see why. What is it about the slopes of the lines that tells me they're perpendicular? Well, if I look at this slope for line A, moving from this point up to right 1. So here my slope is positive 2 over positive 1. This line, begin here, down 1, right 2. So here my slope is negative 1 over 2. So if we compare these slopes, we can see that there are two things that are important for two lines to be perpendicular. The first is they need to be opposite in sign. Notice this slope is positive and this slope is negative. Remember, positive slopes are lines that go uphill as you look at them from left to right. Negative slopes are lines that go downhill. And that should make sense. If they're going to cross at 90 degrees, then one of them needs to go up and one of them needs to go down. So they're opposite in sign, but that's not it. It's also that the fractions here are reciprocals. So this is up 2 over 1. This is 1 over 2. These are reciprocals of each other. The fractions are flipped. So for us to have equations which are perpendicular, the slopes are opposite reciprocals. Two things. So let's first of all, sometimes students misunderstand what we mean by opposite reciprocals. So I'm going to make a t-chart here. So I'm going to put some number on the left, and I want you to kind of predict what the opposite reciprocal is going to be. So if I gave you the number 2, the opposite reciprocal over here, remember 2 is the same as 2 over 1, so the opposite reciprocal is negative 1/2. If I gave you the fraction negative 2/3, then the opposite reciprocal is positive 3/2. If I gave you the number negative 1, then the opposite reciprocal here, this is a little weird. The opposite reciprocal, remember this is like negative 1 over positive 1. Opposite reciprocal, positive 1 over positive 1. In other words, this number is negative 1, this number is positive 1. So these really are opposite reciprocals, negative 1 and positive 1. One more little trick question for you. What is the opposite reciprocal of 0? Well, opposite of 0 is still 0, so there's no change in sign. And if you think of this as 0 over 1 and you try to flip it, 1 over 0, oh, wait a minute, we can't divide by 0. So this is an undefined number. So 0 doesn't really have an opposite reciprocal, but for slopes, this is what you'd be looking for. If you had a slope of 0 and an undefined slope, in other words, a horizontal line, and a vertical line, they would be perpendicular. Because remember, an undefined slope is a vertical line, a 0 slope is a horizontal. And of course, those would cross at a 90-degree angle. Okay, let's get back to the goal here. So I'm giving you equations, and we want to know, do they cross at a 90-degree angle? Are they perpendicular? In other words, I need to know what the slopes are. So for our first example, let's look at 4 lines, A, B, C, and D. So A is y equals 4x. B is y minus 1/4 x equals 6. C is y equals 1/4 x. And D is y equals negative 1/4 x minus 2. So which of these lines, all these are lines, because remember x and y don't have exponents on them. So what lines are perpendicular? Well, let's look for the slopes. Here, what's my slope? Well, it's 4 over 1. Helpful to think of it as a fraction. What's it here? It's not negative 1/4, because remember, this is not in y equals mx plus b. So I need to make it so that it is. So I'll add 1/4 to this side. Sorry, 1/4 x. This will be, 1/4 x plus 6. What's my slope? 1/4. It's the reciprocal of 4, but it's not the opposite reciprocal, so those aren't. So m is 1/4. This line, m is 1/4. So what are a and b? Or sorry, what are b and c? Slope is 1/4, slope is 1/4. They're not opposite reciprocals. In fact, they're the same number. They're parallel. So review the previous lesson if you weren't sure that those were parallel. What's d? Well, here, my slope is negative 1/4. Aha! That's what I want. 4 over 1, negative 1 over 4. A and D, their slopes are opposite reciprocals, so A and D are perpendicular lines. Okay, let's try another example. So this time, again, remember, we're still trying to go from some equations and figure out whether or not they correspond with perpendicular lines. Perpendicular. So are they 90 degrees? So here, let's try y minus 1 equals negative 5 times x minus 6. And y equals 1/5 x plus 2. So these are not, this one here on the left, which I can call line A, and this line B. Line A is not in y equals mx plus b, which is what I want in order to predict the slope, the number in front of x. So I need to make that happen. So I'll distribute this negative 5. Negative 5 times x is negative 5x. Negative 5 times negative 6, that's positive 30, negative times negative. Add 1 to both sides. So I get y equals negative 5x plus 31. What's my slope? Negative 5 over 1. How about line B? My slope is 1 over 5. Aha, those are opposite reciprocals. They are perpendicular. Let's look at one last example. So if I gave you y minus 3/5 x equals 7, that's my line A, and my line B is y equals 5/3 x plus 2. Are these lines perpendicular? Well, let's see. At first glance, it almost looks like they are. This number is in front of x, but again, notice it's not in y equals mx plus b. So notice how often over these videos we've been talking about this simple equation for a line. It's extremely important. So I'll add 3/5 x to both sides, and I'll get y equals 3/5 x plus 7. The right side, y equals 5/3 x, so my slope on the left is 3 over 5. My slope on the right is 5 over 3. Are these opposite reciprocals? No, they're reciprocals, but not opposite. Only one of two conditions is met. They are not perpendicular. Are they parallel? No, they're not that either, because remember, for parallel, they need to be the same number.